Okay. Yeah, good. Hi, I'm Mark from Verbos of Electronics. We are a company originally from New York City, but based in Berlin since 2017. Today, we are going to show the Voltage Multistage 16, which is an analog sequencer that is based loosely on, not loosely, based on the Voltage Multistage, an 8-step module that we've been producing since we started the company 10 years ago. But in addition to expanding from 8 stages to 16, in the process, I've gone back to the drawing board and changed the core of the sequencer from using CMOS counters and decoders to using discrete transistors. Of course, most of the time when discrete transistors are used in synthesizers, it's because they sound nice when they distort or they're unstable and it's cool in audio paths. So conventional wisdom is that there would never be a reason to use them in a sequencer. But in this case, there are a couple advantages that come with it. So briefly, a little history about analog sequencers in general. The first analog sequencer ever made was, at least commercially, was the BOOCLA-123, which was an 8-stage simple affair that was part of the 100 system in 1965. The original version that Don Buchla brought to the San Francisco Tape Music Center, according to Morton Subotnick, didn't even loop. It just played through the 8 stages because the intention of it was to replace analog tape, tones recorded on analog tape, cut up and assembled together. But quickly, Morton Subotnick had the idea that it should loop around, and so it became what we now know. The second generation of analog sequencers that Buchla did was the ones for the first ones for the 200 series, the 246 and the 245, which largely this implementation is based on, and those individual cells that are made from discrete transistors are effectively, each stage has one of those, and that's effectively a memory that will hold when that stage is selected, and in the process of it engaging, it disengages all the other ones. And in this process, we get the ability to, in multiple ways, trigger the same stages. So in this context, we're able to step it along in a classic analog sequencer kind of way from an external pulse or from an internal clock. We're able to excuse me. We're able to address it with an analog voltage, or we're able to send individual gate outputs that will select any of these stages here that are jump to them directly. So a consequence of this is that we can, for instance, grab any stage, go from any stage to any stage. But not only that, we can do things like jump from one point to another with a loop inside of it. So for instance, something like this could be started at the beginning of a bar in sync with drums or whatever. And then at any point, like the beginning of every bar, jump back to the beginning. But there could also be multiple loops nested in. And also, we can address it using the analog address, like is familiar from the old voltage multistage. But the big difference here is that in the old voltage multistage, when we put it into the analog address mode, the gate would go high and just stay high the whole time. But in this case, this core will send out, every time that a stage is engaged, a pulse is put out to reset all the other stages, and we capture that pulse as it comes out. So now, when the analog voltage address is changed, then we get gates that we re-trigger the internal clock, which is sending out the so-called ref signal, which is a bit like a decay-only envelope generator. So using this, it becomes possible to do something like a Morton Subotnick type of random addressed from an analog varying voltage or a random fluctuating voltage or anything else, completely separated from any sort of grid or rhythmic pattern. And we get also the slides. The original voltage multistage was built on the idea of taking the concept from the Buchla-Marf, which was largely the 70s version of the ultimate analog sequencer that had the ability to use the bank of sliders as basically any type of control voltage generator, whether it was an analog sequencer or a multi-stage envelope generator or an LFO of any shape or a multitude of other, a quantizer. And this can do all of that stuff, but then with the addition of these new functions, we can explore some new creative ideas. And for me, this was largely conceptually drawn toward the idea of not always having a 16th note, a grid of 16th notes chugging along. I mean, of course, it's funny to say that while releasing a 16-step sequencer, but the possibility is there to have multiple sequences happening in different sections that can then be jumped to in different parts of a song. Like, for instance, if I had this. And now I'm just jumping between them using button presses, but of course this could be automated from a master sequencer or from a computer or from a keyboard or whatever to jump to these different sections. existing functionality of the holds, the sustains, and the enables are still there as well. The enables and the sustains are a way of if you patch from one of the stage outputs into enable, then the sequence will only pass through that section while a gate is going into the start input or the start button is pressed. If you patch from a stage into the sustain input, then it will not pass, the sequence will not pass through there while a gate is held or the start button is held. So in that last patch, there was the combination of it being in two different sections of the same setup, enable and a sustain. Okay, I'll show a couple more. I think I'm basically finished, but I'll just show a couple more improvisations. Thanks.